Welcome back to the course on computer network and internet protocols. So, in the last classes we are discussing about this software defined networking concept. So, today we will see the implementation of a software defined architecture, software defined networking architecture and in a network emulator platform called Mininet, and we are talking about this open flow protocol. So, we will see that how you can utilize this open flow protocol on top of a Mininet architecture to send or receive packets or to emulate a network topology inside your computer. So, let us have our journey on this Mininet and open flow controllers. So, till now we have earlier looked into different socket programming aspects. So, you can actually in Mininet you can run all these different socket programming and see that the packets are actually traversing in the network. Now, to capture the packets in the internet, we have a nice traffic analysis tool called Wireshark. So, let me first show you a demo of this Wireshark and see how you can actually capture the packets and analyze individual packets in the network. So, here there is this Wireshark interface. So, let me just open it from the scratch, so that the things become easier for you. So, we open the Wireshark tool. So, in that Wireshark tool, this is the Wireshark home screen. Okay, so, here you can see all the interfaces which are there in this machine, where you will be able to capture the packets. Now, this particular machine, it is connected to the wireless LAN here you can see it is connected to this academic SSID to the Wi-Fi router. So, we use this WLAN 0 interface, where it is receiving some packet. Here you can see that there is a small graph which is going on. So, it basically capture the packets which are there. So, let us start capturing the packet in WLAN 0 interface. So, here it is capturing the packets in WLAN 0 interface. So, we will open some website. So, let us refresh this Google website or go to the Gmail website, so that we can get certain packets. Now, come back to the Wireshark, stop the Wireshark interface, and here you can see all the packets. So, you can see there are lots of packets where the protocol field. So, here we have the protocol field. The protocol field is GVSP. So, this GVSP is something called GIE Vision protocol, which is used in TeamViewer kind of application, which currently I am using for recording. So, it is capturing lots of such packets, GVSP kind of packet. It should also capture certain TCP packets. So, here is some TCP packets you can see. So, here are the TCP packets. Now, whenever you are selecting one of these packets, so let me choose one packet here. So, the protocol it shows as TLS version 1.2, which is the transport layer security encrypted TLS encrypted packet. So, the Google, whenever it sends the packet over the TCP protocol, it uses TLS to ensure the security at the transport layer. Now, inside this packet, if you look into this second window, this second window actually gives you the packet details at the different layers. So, this is a nice way to visualize the 5 layers of the TCP IP protocol stack. So, here let us start looking into again this top down approach, the way we are following the course. So, here you can see that you have this SSL packet, which is the encrypted data bits that we have. After that, we have this HTTP header. So, in that HTTP header, we are connecting to a proxy. It just contains the proxy information, because the packets that we are sending from this machine, it is sent to a HTTP proxy server, and from that HTTP proxy server it is going to Google. So, the packet which is sending to Google, it is inside that secure socket layer, that layer which is the encrypted data. So, you can see that it contains this application data protocol. It says about HTTP over TLS. So, here it gives the application data, the TLS version 1.2, the length and the encrypted application data. So, this is the encrypted part of the application data. So, there are 3 different TLS record blocks. So, the entire data is divided into 3 different TLS blocks and that contains the entire application data. Then this HTTP extension which contains the proxy information. Then we have the transmission control protocol or the TCP port. So, you can see that the TCP details are there. So, here my source port is 8080, the destination TCP port is 54768, the stream index is something like 1, the single stream, the segment length, it contains the TCP sequence number that we have seen for the transmission control protocol, the next sequence number, the acknowledgement number and the header length, certain TCP flags. So, in the TCP header there were multiple flags. So, those flag bits are here, the window size, the receiver advertised window size and accordingly the calculated window size and the checksum field, the urgent pointer, then the TCP option field and the sequence and the acknowledgement field. Then you can look into the IP header. The next header is the IP header. Inside the IP header you can see that the source address and the destination address. Now, the source address that I have 172.16.2.30, that is the IP of the proxy address that we have in our IIT Kharagpur network, and the destination address is 10.146.58.130, that is the address of this machine. So, if you just try to see the IP of this machine, you can see that say so, in the Ethernet address, the loopback address, well, so here you can see that the WLAN address is connected to the wireless LAN interface. So, the address is 10.146.58.130, the address of this machine. So, here also the destination address is 10.146.58.130, the address of this machine. So, the packet has been received from the HTTP proxy that we have in IIT Kharagpur to this machine, and the different field in the IP header. So, the IP header length, the flag bits in the IP header, the fragmentation information, then the upper layer protocol. So, it is using TCP protocol, then the source destination, this IP layer header information. Then you have this Ethernet information. So, the Ethernet information you can see from here, and finally, the link layer information. So, the data link layer has 2 subparts, the logical link control and the MAC. So, this frame information that is coming from the MAC and this Ethernet information coming from the LLC. It contains the packet arrival time, the epoch time, the frame length and different other fields which are there to indicate the link layer information. That way, using Wireshark you can actually look into different type of packets. Say for example, you can see that this is a TCP SYN packet. So, it is marked as a SYN. So, if you look into the TCP header for this packet, well, yeah, the TCP header. So, if you look into the TCP header for that packet, you can see that the SYN bit is set. So, it is basically a SYN packet to initialize a TCP connection. So, you can see that a SYN is, so here you can see interestingly the TCP three-way handshaking mechanism. So, the SYN packet has been sent with sequence number 0 and certain window size, then you can see a SYN ACK, then followed by another ACK. So, this three-way handshaking is happening here. So, that way using this Wireshark tool you can actually capture all the packets which is coming in your machine, and you can analyze them, you can see what are the different packets coming to your machine and how to process those packets, look into different header fields at a different layer of the protocol stack and explore it further. Okay, so that is a brief idea about how you can do the packet analysis using Wireshark. Okay. So, next we will look into that how you can emulate a computer network in a single machine. So, that is the emulator platform which is again a SDN based tool that we are going to discuss in little details. So, in computer network, the best way to learn a computer network is experimenting it on the existing network. So, that is always. So, if you run your own protocol, if you say design a protocol, implement it and make a run on your network. So, that is the best way to do, but the problem is that this kind of existing network, it may not be available for everyone. So, to get access to an existing network is a difficult thing. So, sometime it may happen that you have a limited access to the network. For example, we have certain limited access in IIT Kharagpur network. You cannot run anything over the IIT Kharagpur network because it is a public network. And if you want to design your private network or want to set up your private network, it is expensive to make a setup of your private network. So, that is why what we do, we try to emulate a network topology in a computer. So, there are multiple simulation platforms which has been used historically to understand the behavior of a computer network, but simulation platform has many limitations because it is not using the exact protocol stack which is running inside your machine. So, that is why many of the time a simulated network does not give you an ideal information about how your protocol can perform in a real environment. But on the other hand, the emulated network has that capacity. So, in a case of a emulated network, the difference from the simulated network is that you are not simulating in a hypothetical or a virtual environment. Rather, what you are doing, you are utilizing the network protocol stack, the implementation inside the kernel itself, the actual implementation which is going to run in a real network, and on that emulated platform you are testing that how the performance of your network is going to be. So, the advantage is that it is independent of the existing network and it can be set up as required. Okay. Now, here are the different parts or different components of computer networks in a physical network. So, you have the routers, you have the switches, you have different host and the server, and you have the link. Now, in a virtual domain or a emulated domain, whenever we are emulating it using this Mininet platform. So, we call Mininet as a network inside a computer, a emulated network inside a computer. So, these routers are implemented using something called a virtual namespace for legacy network, or Open vSwitch for software defined network. So, Open vSwitch is a tool chain which provide a switch implementation in an open platform or open source platform. You have that Open vSwitch implementation, and using Open vSwitch you can emulate a switch using the kernel protocol stack which is there in your Linux operating system. Then a switch can again be emulated using a Open vSwitch platform. Host can be emulated using a virtual namespace. A namespace is basically an instance of the protocol stack which works like a individual host. So, you have this entire protocol stack implementation inside your computer. Now, you are creating a virtual instance of that protocol stack and emulating it as an individual host. So, this entire architecture you can just think of the way we do the operating system level virtualization. So, I think that you have heard about this kind of virtual machine and the tools like VirtualBox. So, in a tool like VirtualBox, what we do the operating system level virtualization. So, you have this VirtualBox, on top of you can have multiple VMs which are running, and inside every VM you can run one different operating system. So, one VM can host a Ubuntu operating system, another VM can host a say Windows operating system, a third VM can host a Fedora operating system, and all these things can run on top of a host operating system. In a similar way, here we are emulating the network using this virtual namespace and a virtual switch concept, where the network protocol stack implementation is there inside your kernel, and we are creating a virtualized instance of that protocol stack. So, whenever you are constructing a virtual host, that means you are taking a virtual instance of the entire TCP/IP protocol stack of the 5 layers and considering it as a virtual namespace. So, the term namespace actually indicates a virtual instance of this end-to-end protocol stack. So, you are taking a virtual instance of that and considering it as an individual host. Now, if you are going to implement a switch or a router, then at the layer 3 of the protocol stack, you need to run the routing functionalities, or at layer 2 of the protocol stack, you have to run the switching functionalities or layer 2 functionalities. So, that you can implement with the help of this Open vSwitch. So, the Open vSwitch will adapt the virtual switching functionalities or the routing functionalities on top of that namespace, the protocol stack namespace. And then you can emulate the links, the physical links using virtual links. Now, this is a kind of simple computer network. In the physical domain, you have one host which is running, say, a browser like Firefox. It is connected to a network switch or a router that is again connected to a HTTP server. So, using the browser, you can browse the data from the HTTP server. Now, the same thing you can implement inside a single machine. So, here you have your Linux kernel. In that Linux kernel, you have this Open vSwitch kernel module, which runs the switching functionalities by taking a virtualized instance of the TCP/IP protocol stack, and then you have two different namespaces, host namespaces. So, these two different host namespaces again have a virtual instance of these 5 layers of the TCP/IP protocol stack, and there in the application side you are running a Firefox, then you have a Linux kernel which has this virtual implementation of the protocol stack, and then the Ethernet 0 which is a virtual link which is connected to this Open vSwitch kernel module. So, it is connected with this logical switch or the virtual switch, and the other host namespace you have HTTP server running at the application, and the remaining part of the protocol stack along with the virtual link through this ETH0 which is being connected. So, that way the physical network you can implement in a machine using this virtual instances of the network. So, now how you can create such kind of topologies in a network, in a computer. We can use the Mininet tool. I will show you a demo of that Mininet tool, but before going to that, just showing you some simple commands inside the Mininet tool. So, this Mininet tool you can, this is an open source tool, you can install it from the Mininet website. So, from the Mininet website you can even get the image under different kind of operating system, or you can also get the source, you can compile it from the source and install it to your Linux based machine. So, in the Mininet command, if you type the command like mn is corresponds to the Mininet --topo single 2, what it will do? It will create a topology like this. It will have a single instance of the switch and two different hosts. So, if you make it mn --topo single 3, then you have a single switch with 3 different hosts. If you make it as mn --topo linear 3, it will create a linear topology of the 3 switches and one host will connect with each of the switch. So, this is the topology corresponds to that. And then if you want to create, say, a complicated topology, so here what we are doing, that we are creating a topology like this linear 2 3, and this is a kind of SDN topology that we are going to implement. In the last lecture we have discussed about this SDN architecture. We have the switches and the switches are connected to a controller. So, that thing we are going to emulate here using this SDN Mininet networking platform. So, what we are going to do, we are having this mn --topo linear 2 3. Linear 2 3 means you have a linear topology of 2 switches which are being connected and 3 hosts are connected to it every individual switches. And then we are specifying -- controller equal to remote. That means we are having a controller which is there in a remote machine, and that controller is connected to the switches. Now, in that controller you have to load individual controller software. So, in the last class we are discussing that there can be multiple such controller platforms like Ryu, like that POX, like Open Daylight, like Floodlight. There are different kind of controllers. You can pick up your favorite controllers and attach it with this virtual controller that you are designing. And then with that virtual controller you can actually try to do the experiments by setting up, by writing your code inside the controller, by writing your network application inside the controller and then running it over this kind of emulated network. So, now let us go for a demo of this entire procedure. So, what we are going to do, is first we okay. So, first we will run a mininet instance we create a topology of a single switch and 3 different hosts. So, let us do it sudo mn minus minus topo. So, you have to run it using the sudo instances because it run as a root. You are going to access the kernel protocol stack. So, that is you require the root access single comma 3 the way I have shown you earlier, like we have a single switch with 3 different hosts connected to that switch. Then minus minus mac minus minus controller remote minus minus switch OVSK. So, here it says that I am going to have a controller which is going to connected with the switch, and those switches are of type OVSK switches. So, I have to give the root password. Oh, sorry, I have made a typo here, it should be controller. Okay. Now, you can see here what has happened. First, whenever it is trying to add the controller, it was not able to contact the remote controller at the local machine. So, we are saying that we are going to run the controller in the local machine. So, the controller normally runs in 2 different out of the 2 different ports 6653 or 6633. So, it is searching for the controller, but currently we have not executed any controller. So, it was not able to find the controller, and it has added 3 different hosts H1, H2 and H3 and added a switches called S1, and the links are H1 to S1, H2 to S1 and H3 to S1, a kind of star topology. So, 3 hosts are connected to one switch. So, it has configured the 3 hosts, started the controller, but the controller it was not able to connect, and one switch has been started. So, now you got the mininet console here. Now, from that mininet console, if you try to say ping something, so we make the command as H1 ping H2. So, whenever we write H1 ping H2, that means from the virtual namespace of H1, the protocol stack which is there, the virtual protocol stack which is there, from there we are going to execute the ping command, and we are trying to ping the host H2. So, here if you try to ping it, you can see that it is not getting pinged. So, it says that the destination host is unreachable. Similarly, if you try to ping from say H2 ping H3, none of the machines will get pinged. It says destination host unreachable. Now, let us run the controller. So, what we will do under this mininet directory, we are going to use the Ryu controller. So, we are going to the directory Ryu and starting the controller. So, OVS VSCTL. So, this OVS VSCTL command is used to start a controller and attach it with a corresponding OVS switch. Set bridge, we are trying to set the controller in the bridge mode, and it will be connected with S1. So, S1 is going to work as a bridge mode with which the controller is getting connected. Then protocols equal to OpenFlow 1.3. So, we are specifying that we are going to use OpenFlow version 1.3 at my protocol. Okay, SMRL. So, the password. Now, we are going to start the controller. So, what we have done here, we have with this OVS VSCTL command with this S1 which is working as the bridge mode. with that we have configured it with this OpenFlow version 1.3 protocol stack. Now, we are going to run the run the controller. So, to run the controller, we are going to Rue Manager, going to run Rue Manager in the verbose mode. So, that we can see what is going to happen here, and the controller program that we are going to run. So, on the controller you have to run certain applications. So, that application will take care of configuring your switches that we have learned in the last class. It will configure the switch and it will install the forwarding rules inside that switch. So, here we have written a Python script which is actually a default Python script used inside the Rue controller, and that Python script actually works like an application of forwarding manager. It helps you to forward the packet from one machine to another machine. So, we are going to run that one. It is simple switch with version 13.py. So, that is the Python application which we have written, or indeed it was a default application in Rue. Once you install Rue, you can get that as well. So, that particular application we are going to run here. Okay. So, it has executed that one, and after that it has getting connected with the corresponding switch. Now, let us try to run it. H1 ping H2. Now, you can see it is getting pinged. Okay. And when it is getting pinged, let us look into few events which are happening here. Here you can see there was some event which has been logged. So, this event you can see certain packets are coming to the controller, and based on that packet it is configuring the corresponding switches. So, the controller events are being logged here, and here it is getting pinged, and we have an interesting observation here. If you look into the response time of the switches, so you can see that the first packet that was sent, it has a longer time. It has taken a time of 4.84 millisecond, whereas the remaining ping packet, it has took around 0.16 millisecond, then 0.03 millisecond, 0.03 millisecond, something like that. But the first one has taken certain more time. Why that is so? If you remember in the last class that I have discussed that how this entire controller architecture is going to work. For the first packet, whenever it reaches to the switch does not have any information about how to process that packet or how to forward that packet. So, what the switch has done, the switch will send or generate a OpenFlow event which will reach to the controller. So, the event we can see in the other tab, the OpenFlow event that have been generated. So, these OpenFlow events will be generated and it will be sent to the corresponding switch, and then that particular switch will send that event to the corresponding controller, the Rue controller application that we are running. So, that particular application, the switching application, it will generate the rules and configure the switch with that particular rule, and then the packet will get forwarded. And during that in between time, the packet will remain inside the buffer of the switch. So, for the initial packet, we see a certain longer delay. But for the remaining packet, the delays are less. Again, if I run it, you can see that the delays is comparatively less. Only for the first time, it has took that initial longer time. Similarly, now in this case, if I run it in a different case, so earlier I have done H1 ping H2, now say run it from the H2 host. So, if we run the ping from H2 host through H3, again you can see that the first packet has took some longer time to forward the things. So, that way you can actually run this entire controller and the switches and emulate the topology by using this Mininet emulator, network emulator platform. Now, briefly, and you can see here that all these events have again executed for different nodes. Now, let us look into the application that we had written in Python. So, I will quickly show you the application which is there app. So, inside the app directory you can see that there are multiple applications which are there. So, you can actually play with these applications which are there and then start writing your own application using this Python programming. So, simple switch 13.py. Okay, so here what we basically do, a simple switch 13 class has been defined, and inside that we are defining different functionalities. The initialized functionalities, a switch feature handler which handle different features inside the switch, and then the interesting part is this add flow thing. So, this add flow will add a new rule corresponds to a new flow. So, what it will do? This add flow it will call this packet in handler. So, this packet in handler actually handle one open flow packet. So, whenever a packet in event occurs, that means a packet is waiting at the switch and you have received that packet in event at the controller side. So, what we are actually doing? So, you can see that we are extracting the port. We are extracting the packet parameters, the packet equal to packet message.data, then the Ethernet header. From the Ethernet type, we are looking into the type, and then we are taking the source address and the destination address from the Ethernet interface. We are looking into the data path ID and then generating the forwarding rule. So, here the forwarding rules are generated. We are learning the MAC address. So, here we are doing the forwarding. So, the forwarding is done via the MAC address. In the later lecture, you will learn how you can use MAC address for do the forwarding. So, these forwarding rules are being generated. So, based on that, we are generating the output port. So, where the packet will be forwarded next, and accordingly the action has been defined, and then we are installing a new rule in the switch. So, this new rule are we did with this add flow command in the data path, the new rule is being installed inside the switch. So, then we are making a packet out event. So, this packet out event will actually send information from the controller to the switch, and it will send that message to the data path from the data path. So, that way so it has its own construct. You have to learn that what are the different functions or different classes which are being available in the Mininet, and accordingly try to learn this program. So, I will suggest you to explore this further, to explore this code if you are familiar with the Python language, and start with playing with this kind of code. And if you are not familiar with Python language, do not worry, there are other controller as well. So, for example, there are this Open Daylight controller which is written in Java. You can try with those controller as well. You can choose your controller which is preferable to you and start playing with that. So, that is something we wanted to discuss in this particular class. Hope you got an idea about how to process this entire thing and run a SDN controller in your local machine. I will suggest you to play with this Mininet emulator platform, and the different kind of protocol that you are learning, execute it on top of that. So, you can even execute a socket programming from this individual host, just like we have executed the ping application. You can run your socket programming application and run it there. So, explore it further. So, hopefully, you will get a nice understanding or nice insight of this network protocol stack. So, thank you all for attending this class.